Conventional surveying can be labor-intensive, timely, and expose workers to hazardous terrain. Drone lidar has helped expedite the surveying workflow for the team at Adam Surveying, especially when their customer quickly needs verification and volume measurements to ensure the project is in compliance and completed on time. After collecting drone lidar data from 2 large area UAV projects, Adam Gribben, a survey tech and SUAS pilot for Adams, goes through the final steps to process and visualize the data for Graham Associates.
All right, so we're done with the collection from what we did yesterday. We pulled the USB out of the MD lidar 1000 HR and dropped the files into our desktop here. So we go straight into MD Infinity, log into your MD Infinity account, go to trajectory processing. So once it's downloaded, you're on to georeferencing. This is what it will eventually look like once you have it georeferenced. This is their viewer that's used. What you're seeing here on the red arrow is the flight path of the bird, and then the blue stuff is what we collected. So you'll be presented with this screen. We're gonna go straight to georeferencing. Once you get your point cloud done, you'll see if we leave it rolling here, it takes better part of maybe 5 minutes for it to process that, maybe 3 minutes. To get to this final deliverable, the next step from georeferencing is I've got to extract a surface from that point cloud. What we're seeing in this visualization is distance from a set plane, so I can start seeing some of my pads appearing insofar as what we collected. The main reason we use this application is for extracting the ground from here. So I can either classify the ground, just see what it believes is the ground classification, and once I've done that, I can then extract perhaps an elevation grid. If I want to pull out a 10 foot by 10 foot surface as though I went out there with my GPS or my robot, we can hit a 10-foot grid, no problem. Let's see, let's go take a look at Trimble Business Center. Trimble Business Center I use a lot for QCing the data. What you're looking at here is a visualization of volumes. This is kind of your construction verification. This screen on the bottom here is a vertical cut plane. I think I went around the building pads here just to see the difference of the flight in February is the top line, and the flight that we did yesterday with the MD lidar 1000 HR is a much denser point cloud, as you can see. For some quality checking, we take ground shots for ground truthing, either GPS or robotic, and then we'll compare that to the surface that we make with a little report called points to surface, and that lets me know that according to my ground truth, we disagree by about 1/10.5, which a tenth of a foot, 1.2 inches. And in dirt, that's all day long. I got no problems with 1/10.5 from LiDAR data going over the actual surface ground truthing. So that's a good product. We're ready to move on for that. So the final step is after you've done your extraction, so I'll generate those points that are in CSV form from TopoDot, then I'll bring them in to Civil 3D via their survey module. Yeah, so once the deliverable has been made, the deliverable needs to be delivered. So for us personally, I'll package up the DWG, the CSV file, and the ortho in a surface export in XML. Zip all that up, put it into Microsoft OneDrive, and send the client or the project manager the link. So we've completed our collection of Spradley Farms, which is where we were on day 1. We went then to a job site called Karis. This is a much larger project. This took 13 full flights to complete, which we did over the course of a day and a half. This is an 800-acre site. Big acreage sites are going to have a lot more of everything. So after we've done our quality checks and whatever software you care, ours is Trimble Business Center, to compare ground shots to the data to make sure I'm not dealing with trash data or a coordinate mismatch, we move into TopoDot for us to do some extraction of this point cloud. This visualization you're seeing here, while kind of kaleidoscopy, is contour lines. So you're seeing repeating colors at about every foot interval. Off we go to Civil 3D to then bring, like we showed previously, bring those points into a survey database and let Civil generate the surface. We will continue monitoring this site as construction progresses. You kind of saw in Karis where this will be in a few months. So you've got your volumes of dirt that you want to know, and just how is construction progressing. It's like a picture is 1,000 words. Well, add the picture plus a couple billion LiDAR points, and it's worth even more words. Just that resolution of data and accuracy that you really can't get without having this tool.
The microdrone's benefit is the scale of the project. A lot of projects that we have can be 50 acres, but we do a lot of projects up to 1,000 acres, and microdrone just kind of fits that particular criteria very well. Well, with all surveying, we use tools. Over the last 40 years that I've been in surveying, we've had a multitude of different tools, and this was a tool that I recognized early on could be very beneficial to our business. At this point, we look like it's going to be a really good next year and hopefully years to come.